Good evening, everybody. This is Lorenzo Perella again from Physics 116 with Clark Wellman. Today I'm going to be going over my third lab, which talks about Bernoulli's equation and coin jumping. And this is actually a pretty simple experiment that I did at home during the class period. As you can see from this setup, I have four different coins: a penny, a dime, a nickel, and a quarter. And I have to blow on them right over the top to get them from where they are on the table into this cup. In order to do that, once you blow on each of the coins, you can use Bernoulli's equation to estimate the airspeed for each type of the coin. And in order to do this, you first have to rearrange Bernoulli's equation. So to start with, Bernoulli's equation states that the first pressure plus 1/2 of the pressure velocity 1 squared plus the plus delta, no, rho, sorry. The secondary P is rho. Gravity times height 1 is equal to pressure 2 plus 1/2 rho V2 squared plus rho GH2. Now, this can be rewritten as the first, so we know this is at atmospheric pressure and it's not changing in pressure. We can rewrite it as pressure 1 is equal to pressure 2 plus 1/2 of the density of air times the velocity of air squared plus the density of air GH. Now, if we move both parts of pressure over to one side, we get the delta P. And then that, coupled with the area of the coin, which you can see over here, equates to there being equaling to the mass of the coin times gravity. In this case, we're using 10 meters per second to make the calculation simple. That change in P is 1/2 rho of A, which is air, multiplied by the velocity of air squared. Whereas the area, you take pi over 4 times the diameter of each coin squared. For a nickel, our end equation gave us a velocity of 15.2 meters per second. Now, if you equate this to each one of the calculations, as you can see, a penny doesn't require as much, only needing 11.97 meters per second of wind in order to blow it into the cup, 1 inch above the table's surface. Whereas with a dime, it may be smaller, but it requires more wind in order to push it. But the interesting fact of this was that even though the quarter was the heaviest of it all, it didn't need as much wind to be blown up into the cup as the nickel. So that answers the question here in that, do you have to blow the hardest to make the heaviest coin jump into the cup? And it's no. And while the quarter was heavier by 0.67 grams, its smaller thickness coupled with a large diameter allowed for a greater surface area for the wind to blow across. In addition, these two coins' density, which is the mass divided by the volume, shows that a nickel is more dense than a quarter. All of this together notes that while mass does affect the wind's velocity needed to lift it, density and surface area are key components to this experiment, in that you need to equate not only how heavy something is, but how much surface area it can lift, surface area the wind is going to get in contact with. As you can see, the difference between the nickel and the quarter has a larger area than the nickel as well. When coupled with the diameter, thickness, and mass, those illustrate that while it's smaller, it just takes that much more energy for the wind in order to get it into the cup versus the quarter. And the same thing can be seen with the penny with the penny versus the dime. For while the penny is heavier than the dime, it takes more wind to lift it because the area of that coin is small. Area of that coin is smaller, meaning you need to blow harder for the wind to really catch it as it blows over the surface and into the cup. With all these coupled together, it's a very interesting illustration. Oh, and I should also mention again that when you're blowing over the coin, you lower the pressure, which is the atmospheric pressure, over the coin, and the difference in pressure causes the coin to go from the bottom to into the cup. All of this in tow allows this experiment to be possible. Thank you for tuning in. This was Lab 3 with Lorenzo Perella from Clark Wellman's 116 physics class. Have a wonderful evening.